Artificial insemination in pigs. Besides dairy farming, pig keeping is one of the most important branches of animal husbandry. Pigs make up about 1/3 of today's animal production. To maintain such high productivity rates, good reproductive performance is essential, and this can best be achieved by artificial insemination. The boar stations are isolated from other pig-keeping installations. Locks and rodent-proof fences contribute to the disease prevention measures. Further hygienic measures serve to secure the interior area. Use of the shower lock and a complete change of clothing are mandatory. A further preventive measure is the disinfection bath at the entrance to the pig house. The straw for the pig litter is also kept in the isolation area. At the insemination station, the boars are washed before semen is collected. This hygienic measure is, at the same time, an element in sexual preparation. Ample establishment of contact with the dummy, accompanied by the typical gnashing behavior, signal the imminence of mounting. Pressing out the preputial diverticulum lowers the germ content of the ejaculate. After grasping the tip of the penis, ejaculation is triggered by manually imitating the cervical contractions of the sow. The pre-ejaculate is run off. During the 5-minute ejaculation, a high sperm dose fraction is first produced, followed by a phase with a lower sperm count. A gauze strip covering the collection vessel filters off the grainy mucus secretion of the bulbourethral gland. For storage of liquid semen, the entire ejaculate of 150 to 350 milliliters is used. For frozen semen conservation, only the sperm-rich phase is taken. In larger stations, the ejaculate is dispatched pneumatically in plastic bags from the collecting room to the lab. The volume is established by weighing, and the ejaculate is then subjected to rough evaluation. Rough evaluation is followed by microscopic assay. Sperm motility and morphology provide useful clues about the quality and keeping properties of the semen. In computer-aided assay, the optical image left is transformed into a digitized image right. Motion grading is made possible by recording the sperm paths. The assay includes measurement of the concentration of motile sperm, their mean velocity and linearity, as well as the density of the semen sample. Natural semen should contain at least 150 million sperm per milliliter and exhibit a forward motility of more than 70%. The proportion of morphologically deviant forms, excluding plasma droplets, should not exceed 20%. A high incidence of plasma droplets does, however, indicate insufficient sperm maturity, whereby a difference has to be made between proximal and distal location. Osmotic changes in the plasma produce these looped forms. An acrosome in process of detaching itself indicates early degeneration of the sperm cell. Sperm with pear-shaped heads, like those at top center and bottom right, may have defective nuclear material. Another pear-shaped head, right, and cratering of the nucleus, left. Sperm with a fractured neck are also frequent, as in the center. If the semen conforms to the minimum requirements, final dilution can now take place. With a dosimetric pump, a dose of glucose EDTA HEPIS extender is added in proportion to the total sperm count. By adding bovine serum albumin, the conservation properties of the extender can be improved still more. A single 80 to 100 milliliter dose contains 2 to 3,000 million sperm. Filling is either performed manually or with an automatic filling device, which is advantageous for large AI stations. After sealing, every portion is provided with the bore registration number and information on race, AI station and date of collection. In storage or transport at 18 degrees Celsius, the sperm remains fertile for 3 to 4 days. It is essential to have a proportion of at least 70% forwardly motile sperm in the diluted semen portion. For a longer period of storage, the semen has to be frozen. For this purpose, only top-quality semen should be used. After temperature equalization at 32 degrees Celsius, the semen is pre-diluted with an equal portion of Merck extender and then taken to the cold store. Within the next 4 hours, the temperature has dropped to 15 degrees Celsius. The semen is then centrifuged for 10 minutes at 800 G. After decanting the supernatant liquid, the precipitate is buffered with a cooling extender containing egg yolk and lactose nutriments. For further temperature equalization, the semen is taken to the cold store, where it reaches 5 degrees Celsius after 1.5 hours. Now the cryo-extender, consisting of a lactose egg yolk mixture buffered with 3% glycerol, is added. Finally, the semen is apportioned in 5 milliliter macro tubes. Siliconized steel balls serve as tube closures. The air bubble at the top must be relocated to the middle immediately before freezing to prevent nitrogen from penetrating into the tube. In the first stage, the semen is frozen down to minus 120 degrees Celsius in the nitrogen vapor about 1 centimeter above the surface of the liquid nitrogen. After 20 minutes, the macro tube is transferred to the nitrogen storage vessel, where it can be stored almost indefinitely at minus 196 degrees Celsius. Before insemination, the optimum mating time must be established. Here, the sow's sexual receptivity is revealed by a teaser bore. His nosing activity along the sow's flanks, genital olfactory control, and mounting attempts all indicate estrus. If the standing heat reflex can be induced, full heat is established and the best insemination time is 24 to 36 hours later. Swelling of the vulva is by this time already diminishing. At the height of the heat period, the standing reflex can be induced by human intervention, vulval control, manual flank stimulation, lordosis and riding tests are all positive here. But an exact forecast of the time of ovulation is not possible using these tests. Precise determination of ovulation can be obtained by transcutaneous sonography of the ovaries. The 5 MHz transducer is applied to the sow in the standing position. The first orientation marker is the urinary bladder. Between the intestines, the ovary is now visualized. The ripe follicles show up as round, dark areas. Repeated examinations are used to determine the time of ovulation. In the breeding herd, the presence of the boar is an important factor in stimulating estrus. A twice-daily heat test can help to establish the best insemination time. Pre-estrus is characterized by flushing and swelling of the vulva. A further day elapses before the climax of estrus sets in, so there is time enough to order semen. The insemination technician arrives from the local AI station. The semen portions are kept at a constant temperature in polystyrene containers.
Whatever. Welche Beurteilung sind das?
Die 811.
811 und seit wann steht sie bei mir?
Ja, seit gestern Abend steht da eigentlich.
Seit gestern Abend. Ja, das wird wohl richtig sein.
Jo.
Das nehme ich auch an.
Dann ziehen Sie hin.
Ja, okay. Dankeschön.
The cyclic status of each sow is recorded on the estrus calendar. Insemination is carried out near the boar pen to induce the standing reflex. The reflex can be intensified by the inseminator riding the sow. Cleaning the vulva with a dry tissue before semen introduction prevents the transfer of germs. After insertion, the moistened insemination pipette follows the roof of the vagina with a twisting motion until the tip of the catheter stops at the opening of the cervical canal. The seminal fluid deposited in the cervix will not reach the uterus unless it is injected slowly. From there, it is transported to the oviducts by rhythmical contractions of the uterus. To ensure fertilization, a sufficiently large number of sperm has to reach the egg, as shown here in vitro. An indication of the fertilization chances is the number of sperm cells lodging in the zona pellucida, which becomes visible following enzymatic lysing of the zona. Insemination should usually take 5 minutes or more. After insemination, the data are stored in a small computer.
Der Eber war?
Tago.
Tago, ja. Heute haben wir den 25.04.89. Ja. Das wär's.
Für meinen Betrieb bringt die
Artificial insemination has many advantages for my pig farm. The boar is not overworked anymore, and I can organize the insemination and therefore the farrowing group-wise. All the boars at the boar station are available for pure breeding and crossing, so I only need to keep one boar.
Durch Eigenbestandsbesamung.
An increasing number of pig breeders are now practicing on-farm AI service. There are many economic and hygienic advantages to this method. The knowledge and skills required to perform artificial insemination and the advantages it offers are put over to the stock breeders in regular courses. The advanced state-of-the-art of artificial insemination allows better use of high-quality boars and reduces the risk of disease transmission, thereby increasing breeding efficiency, profitability, and cost-effectiveness.